Good day. I am David Frizzell, and I am presenting a slideshow called How to Find Stuff, Part 1. The Albuquerque Astronomical Society, or TAAS, is one of the largest amateur astronomy clubs in the country. We have over 300 active members. We have a private observatory, a number of telescopes that we lend to our members, and we have an active educational and public outreach program. There are a number of ways that we like to share the science and fun of astronomy. And of course, as you can see, our motto is observe, educate, and have fun. You can find out about our activities on our website and on Facebook. Astronomy 101 is a program where task members, such as myself, present topics of general interest to beginners in amateur astronomy. These programs assume little or no prior knowledge of concept. Each presentation is designed to begin at least 45 minutes to an hour before a regular monthly meeting in the traditional in-person approach to meetings. The Astronomical 101 programs will generally run between about 30 and 45 minutes. The programs on how to find stuff are intended to help you learn a little bit about the night sky and find interesting astronomical objects without the use of a computer, without the use of a mobile app, or without the use of digital circles. This first program will be an introduction to some terms and methods for identifying the night sky, and subsequent programs that I'm planning at this time will use those terms and methods to actually find some things of interest during each of the 4 seasons, as opposed to doing them on a monthly basis. We anticipate that the next program will run in June and will be concerned with the summer sky. The outline for this program on methods will be pretty much as set out here: a brief introduction to a few terms, an introduction to what we're going to refer to as asterisms or patterns within our constellations that are all visible with the naked eye. You don't need any instruments for them. We're going to talk a little bit about what some of those patterns look like. I'll show you some whole sky charts, and we'll use those instead of talking about things with computers. We'll make an introduction to some telescopic objects, and we'll introduce the field of view. We'll do some individual star charts, some star hopping, some viewing plans, and end with some examples. Amateur astronomers study and observe much of the same general objects as do professional amateurs, such as planets and stars and galaxies. Ordinarily, amateurs are not as focused on physical dynamics and nuclear and chemical reactions as are professional astronomers. Amateur astronomy is an activity where participants enjoy observing or imaging celestial objects, and using everything from unaided eyes to binoculars to telescopes and digital cameras. In this program on how to find stuff, Part 1, Methods, by stuff we mean astronomical objects. The astronomical objects we are looking for usually fall into 2 categories: objects that are fixed, that is, they appear in the same place every year, at least on human timescales, and objects that are transient, that is, they move against the background of stars and generally are within our solar system. Fixed or deep sky objects usually include things like stars, galaxies, nebulae, and clusters. When we talk about transient objects, or objects that move across the background of stars, we are mostly talking about the solar system. And of course, that's going to include such things as the moon, planets, and comets. For purposes of this program, we're going to mostly be talking about things that you can identify and find with the naked eye, with binoculars and small telescopes. Things, in other words, that most amateurs use. I need to point out at this time that what you're going to be able to see with binoculars or small telescopes will not be nearly as bright or as colorful as those images I just showed you. Those are going to be things that you would have to have a digital camera for the most part. So there will be quite a bit of difference in what you can see with the usual small amateur telescope. You will also learn that finding most of the usual objects that amateurs look at will require you to have a stable mount for your telescope and some kind of a finder. TAS will have one or more Astro 101 programs, at least at some point, that will help you in locating and using mounts as well as aligning finders and reflex sites. Astronomers have divided the sky, or what we'll call the celestial sphere, into a grid system. And that gives coordinates that you can use sort of as if you were using a map on the Earth. The location of virtually all objects that have ever been seen have been given some kind of a description by coordinates. If you had the right kind of computers, you could find those even faint objects using those coordinates. The odds are if you can name an astronomical object, you can find its coordinates on the internet or on a paper chart or on a paper table. Further, there's an abundance of inexpensive or free apps or for mobile devices or computers that show location details of most objects that you can observe from Earth. With most things that you will want to look at with an amateur telescope, you will not need to use either the grid coordinates of an object or the mobile apps or computers that I've shown you some pictures of. The basic methods that we'll discuss in this program involve observing patterns and learning how to use some simple finding tools. To use the patterns and simple tools, you really only need to understand a few concepts about our location on Earth and the celestial sphere. For star hopping, it is useful to learn a little bit about the field of view of a finder, scope, or reflex sight. You don't have to learn the meanings of these terms to follow the methods in this program, but it might help a little bit. When you look at the sky at night, it appears that we're inside a large ball or a sphere covered in stars. The celestial sphere is an imaginary ball around the Earth. All the objects in the sky can be thought of as having been projected upon the inner surface of the celestial sphere. From the point of view of an observer, half of the sphere would resemble a hemispherical screen over the observing location. Relative to the Earth's orbit around the sun, the Earth is tilted on its axis, an imaginary line that runs from the north to the south pole, about 23.5 degrees. The terrestrial poles are projected onto the celestial sphere. Here in Albuquerque, we're located a little over 35 degrees north of the equator. That is our latitude on the Earth, and it's projected as latitude on the celestial sphere. I will return to that number in a few minutes. The zenith is a point directly overhead. The horizon, and by horizon I don't mean a technical astronomical term, is the boundary where the sky meets the ground, or the sea. The celestial equator is the Earth's equator projected onto the celestial sphere, just like our latitude. Longitude, which is an imaginary line that starts in the north and ends in the south on Earth, is projected on the celestial sphere as the meridian. The ecliptic is the projection of the sun's and planets' paths as seen from the Earth onto the celestial sphere. It is essentially an orbital plane. For all practical purposes, the 8 planets and most of the other solar system bodies also follow that path. Instead of degrees like latitude, the meridian lines are divided into 24 hours. 0 hour, called the prime meridian, is at zenith directly over Greenwich Observatory in London, England. Now we need to talk about field of view. This is a sample photograph of a portion of the night sky that you can see with the naked eye. Even this view is more limited than your eyeballs can see all at once. When you look through a telescope, or its finder, or through binoculars, you see a much smaller portion of the sky than you can see with the naked eye. What you see through an instrument is called the field of view. Here are a couple of star charts. This goes along with what I've been discussing with you. Now, the first one I'm showing you is a star chart with a dark background and white stars. This is a fairly large star chart. This is one that has a nice laminate on it, and it's the kind of thing you'd have with you out in the field on a damp night. Well, of course, you don't want it to be too damp outside, but this gives you a little bit of protection from dew getting on your paper. This is a fairly large and expanded star chart. Now, the next one I'm going to show you is a little smaller, and it's kind of the negative of the night sky. This is a white background with dark stars, as you can see. So the point about this, though, is that with the lighter background, you can do a couple of things that make it easier to prepare. And it also will be easy for me to illustrate what I've been saying about field of view. So imagine, if you will, then, if we've been talking about the field of view, that if you had some circles, these rings that you see here, these would be rings that you can impose over the star chart. So, for example, if you looked at the two stars on the Big Dipper, and I'll be talking about them in some detail, here they are on this expanded white background chart. This ring barely fits over the two stars. They barely fit in. Well, that happens to be approximately 5 degrees, which is also approximately what you would see in your finder scope. That much of the star field, and you would see the two brighter stars at the end of the Big Dipper's bowl here, and also a few of the smaller stars, or lower magnitude stars, in between them. On the other hand, if you were just looking through your eyepiece of your telescope with this much smaller ring, representing approximately 1 degree, well, you can see that you'd see the larger magnitude stars, but you're going to see a lot fewer stars in between, and you can therefore almost immediately see the advantage of moving about in the sky using your finder scope as opposed to trying to move about in the sky with your telescope alone. Also, I'll say that the star chart with the white background and dark stars is easier to use during the daytime when you're preparing for your evening's activities. That is, when you're planning what it is that you want to see during the evening and doing a kind of preparation plan for your night activities. If you don't already know, a finder scope, or a reflex sight, is the smaller instrument attached to your telescope. And even though this program isn't about how to align your finder scope or other details about finder scopes, I think it would be relevant to go ahead and show you a couple of ideas about what I mean when I talk about a finder scope. So finder scopes are essentially everything as you might see on a scope, from as small as this little guy right here to something as large as this fella right here. Sometimes they're called reflex sights. Here's a sample of a little small reflex sight. Here's a more complicated looking finder scope that you might see in some instances. And then finally, here's a finder scope actually on a small refractor. I'll just get this over here for you can see how it's attached. But of course, the important thing about this is that finder scopes give you a larger field of view to help you move about so that you're not relying on that tiny little field of view through your telescope eyepiece. And of course, using the finder scope allows you to compare what you see within the field of view of the finder scope more easily when you compare that with what you can see in your star chart. You get more stars and therefore can see more of the patterns. Following up with what I just showed you with star charts and field of view with the copper rings, here is a chart of the Big Dipper asterism. And we're going to spend a lot of time with that in this methods program. Imagine holding up to that, as I did in the demonstration, something like a paper towel or a toilet paper tube. You see that circle imposed over the two bright stars at the end of the Big Dipper? That's about all you're going to see through the finder scope as I discussed in the demonstration. What I didn't tell you during the demonstration is those two stars are called pointer stars, and we're going to spend some time with that a little bit later in this methods program. The Big Dipper is an asterism or a star pattern in the constellation Ursa Major, or the Big Bear. Most people can pick it out pretty easily. It's common to draw a line between the major dots, or brighter stars, to illustrate the pattern. I have learned over the years that a few people don't know what a dipper is, particularly as a function of age. So just as a reminder, this is the shape of a sample dipper, a bowl with a long curved handle. Using the field of view of the finder scope and comparing that with the view in the star charts is part of how you will use star hopping to find some stuff with the telescope. So that's it for some of the terms and concepts that will help in the methods of this program. As I said, the primary focus of these methods will be locating and using patterns formed by the brighter stars, and then using star hopping to find actual telescopic objects. The ancient constellations were very imaginative, and most of us don't see the mythological characters and creatures in the patterns that we can make out in the sky. Ursa Major, which is the figure in the upper left, of course, is the constellation where we see the Big Dipper asterism. Modern astronomy has divided the celestial sphere into a grid oriented around 88 constellations. We can see roughly 2/3 of those from our latitude. Most of the 88 constellations were adopted from the ancient constellations, and they're given precise coordinates on this grid. Modern astronomy has also kept about 250 of the ancient names given to the brightest stars by the Greeks and Arabs. So if we're looking at this very imaginative constellation, or two constellations of Orion and Taurus, we don't really make out anything like what you see in this picture. But just taking a look at Orion for a moment, there's a modern asterism on the left that is recognized as generally what most people see in Orion. And you can also see that it's very similar to the hourglass shape that I've shown on the right. And I'm going to talk about a few more asterisms as we get into star hopping. And we will use this approach for the 4 seasons in the following programs. So with the patterns that we've just been discussing, the next thing you need to know is where are those particular constellations tonight, or any given night that you're outside and wanting to see things in the sky. You need to know how to nudge or move your telescope around, where to point it, and what to look for. I'm going to refer to 2 types of tools. The first tools I'm going to discuss don't require you to use a telescope, and the field of view is not particularly important for these tools. These tools are fine for just your naked eye. The first tool I'm going to discuss, and the one that would be your choice if you only could pick one out of all of them, would be a star map or star chart. Some monthly charts, such as sky maps, which is the chart on the left, you can download for free from the internet. And as you can see, it has a white background with dark dots representing the stars and the other objects that are that are out on that time at that on a monthly basis. As you can see, it has a white background with dark images. You can get a more sophisticated version that is a fold-out in various astronomical magazines, such as the one from Sky and Telescope on the right. It has a dark background with white images, and you can see that it has a more detail than the Sky Maps monthly map. Another very useful tool is a planisphere. Planispheres don't give you information about solar system objects, but they do show you the fixed stars and objects throughout the entire year. As I prepare this, they range in price from as little as $8 to as much as $25, depending on their features and their plastic coatings. You can find them in many bookstores and on the internet. As with the monthly hemisphere chart, I will return to how to use a planisphere. An ephemeral almanac will give you the dates and times for rising and setting of solar system objects, as well as for information about other major targets as they move throughout the night. Some almanac information is available free on the internet. A very useful almanac is the one published by Sky and Telescope, such as this one that I'm showing you here. And it costs about $5 if you don't have a subscription to Sky and Telescope. It's free if you do. And again, I will return to showing you how to use this as part of the demonstration I'm about to turn to. Now, I'm just showing you some slides of the things I want to demonstrate here. In particular, this is a sky maps chart of the sky. This is actually for December 2020. And you can see, although this is going to be apparently reversed in my camera, you can see that it's marked with north and south and east and west as a way to indicate, sort of how to orient yourself. But maybe what you won't realize until you've done it is how to use it when you're actually outside. So what I want you to think about is imagining this as being directly overhead, and then how you orient yourself using this. So go outside, of course, and after dark, and face south. I know that's going to sound odd, but face south, and then hold the star chart directly overhead. I'm going to scoot down in my chair relative to the camera here, directly overhead, so that as you hold this directly overhead, the North Star, or Polaris, is slightly behind you. And of course, as I say, you're facing south. So now what you see directly overhead should be very similar to what you can make out in the sky in comparison with the sky chart. And you'll use the same approach, by the way, with the Sky and Telescope more complex sky map and other similar sky maps that are printed for 1 month at a time. I've also shown you in a slide what a planisphere looks like, and this is a sample. Again, I think it looks like this is going to be reversed. I don't know if that'll be true when this turns out to be finished product. Anyway, this is a planisphere, and it's optimized for latitudes between 30 and 40 degrees, which most of what we're talking about will be appropriate. And of course, it applies specifically to Albuquerque. It has two sides, one that shows you most of the sky from the north to approximately the celestial equator, and then the back half will also show you the south of the sky, heading on down to about as far below the celestial equator as you can see from Albuquerque. And the way to use the planisphere is to recognize that this covers the fixed items throughout the year by month and time. So if you wanted to find out what the sky should look like on, say, January the 15th at, say, 8 p.m., you would find January, one of these tabs, and you'll see that it's divided up into the days of the month along the outside edge. And then along this edge, you'll see the hour and not divided up into minutes, it's just hours. And you would dial your January 15th down to the mark 8 for the hour. And then this would show you what the fixed objects of the sky should look like on January the 15th. And again, you do the process of looking up at the sky the same way you do with the star charts, namely face south, take this sky and hold it overhead with north just slightly behind your head. And what you see when you look up should match what you see in the sky. The other advantage to this piece, of course, is that as the night changes and if you're staying out late, you can actually adjust your view so that as the hours go on by, you can dial it just a little bit and see the sky as it rotates. And later in the morning, early morning, you'll be able to make out some details that you wouldn't otherwise make out in one of the star charts because it's pretty well fixed for just a few hours at a time. And then the last thing I wanted to demonstrate for you is the almanac. As I said, this is for transitory objects, things that are changing as opposed to things that are sort of the same all the time. And you know, as I said, this particular almanac is going to be for 2021, and you'll want to get one for every year. But what I wanted to illustrate is it basically shows sort of three sets of data. Shows data for when something is rising along this column over here. These are rising times given in hours. Then the middle of the chart is sort of going to be information about where the change is occurring or where the object is rising or setting. And then at the end, it's usually going to be information about that object's setting time. So these are also shown in time throughout the year, and it also illustrates an important point. Let's say we're going to talk about the planet Saturn. Because we're in 2021 now, Saturn is going to have a different pattern than you might have expected if you've been paying attention to the conjunction of things at the end of 2020. So here is when Saturn rises. Well, you'll see it doesn't rise until, after, if we're going to talk about after twilight, it doesn't rise until mid-July. It's still shown, however, as rising if you're staying up late at 3 in the morning. And then finally, if you really stay up till just before it gets light again, well, it actually rises at about 5 at the end of February. So this almanac gives you a lot of details about those kinds of transitory or ephemeral things as opposed to what we might call the fixed stars. To get more details, and in order to see more patterns, you're going to want to obtain some individual constellations. Most of the constellations I'm about to show you come from the International Astronomical Union that has posted these for free on the internet, and they have also worked in conjunction with Sky and Telescope to make these available. So this, for example, is an individual image of the constellation Leo, and you can see the asterism of Leo. This is the constellation Auriga. You can see that it's close to two other constellations that are marked on this chart, part of Perseus and part of Gemini. And speaking of Gemini, this is the asterism of Gemini. And finally, for today, I'm showing you a simple illustration of Cygnus, the swan, with a few of the other constellations on its borders. And here is an indication of where you can download those individual asterisms from both the International Astronomical Union as well as from another company called Stardate, and those are also free. Of course, there are a lot of other places on the internet as well as books where you can also obtain individual images of the constellations or asterisms. I should point out that for any evening that you plan to do some viewing, even though you're just getting started in this, it's a good idea to do some preparation so that you'll know what to look for and what you want to try to catch during the evening, particularly if you're not going to stay out all night. And one of the things to do is prepare something we call a viewing plan, and you can use those asterisms to plan ahead as to what you can expect to see, where it should be in your sky, and then how to hop around within that asterism or within those patterns to find things that you want to find on an individual night. It's also useful that if you have those viewing plans, you can make notes or logs regarding what you saw and record the time you saw it and what you thought you could make out, how much detail you could see. And it's useful to go back later and compare that with what you're able to see at a different time and under different conditions. So I've spent a lot of time already talking about the Big Dipper asterism. And now we're going to spend a little bit more time actually doing a couple of things with it so that you'll understand and appreciate how useful it is. I'm actually going to spend some time star hopping, as we call it, within both the Big Dipper and within the constellation Andromeda. I'm now going to show you how the Big Dipper has the pointer stars that point to the North Star or Polaris. And we're going to star hop a little bit within the Big Dipper to find a galaxy called the Whirlpool Galaxy. And then after I finish going over those things with the Big Dipper, we're going to talk a little bit about the constellation Andromeda. Earlier, I told you that the two stars at the end of the bowl are called the pointer stars. And the reason for that is, as you can see in this diagram, that they point at the North Star or Polaris. As it happens, Polaris is the last star in the smaller, dimmer constellation's handle of Ursa Minor, or the Little Dipper. Later in the program, you'll see how the Big Dipper does other things as well. And finally, you've probably realized that as the seasons pass and the years change, the Big Dipper rotates around the North Star, but those pointer stars always point the same way. They always point at Polaris regardless of the time of year. This is an example of using the Big Dipper to star hop to a deep sky object called the Whirlpool Galaxy. It shows that the Whirlpool Galaxy is a little under 5 degrees, or approximately the diameter of the field of view of your finder scope, southeast of the last star of the Big Dipper's handle. This is the asterism of the constellation Andromeda. It's not a particularly large constellation, and it's not a particularly complex pattern. It reminds most observers of a curved V shape. It also looks a little bit like a fanned out tail of the constellation Pegasus, to which it's attached. We'll talk about Pegasus in the upcoming program for the summer sky. Anyway, all kinds of interesting things are happening around the constellation Andromeda, and it's almost directly overhead here in January at a little bit past 7 o'clock in the evening. Next to the curved V of Andromeda is our sister galaxy, the Andromeda Galaxy. The Andromeda Galaxy is about 2.5 million light years away from us, and has about twice as many stars as our own Milky Way galaxy. This beautiful picture of the Andromeda Galaxy is a digital image viewed by the Hubble Space Telescope. What I want to call to your attention, however, as we wrap up this program, is how you can see the Andromeda Galaxy using the asterism of the constellation Andromeda. Start at the brightest star, that is the point of the V, and count outward as the V opens. Look at that second pair of stars. We are now star hopping from the bright star to the next star pair to the next star pair. That second pair of stars appears to have a companion star to their north, and it appears to be about the same distance from those two stars as they are from each other. That object, a little fainter than the stars, is not a star. It is the Andromeda Galaxy. And in a moderately dark location, you can see that spot with your naked eye, although it's 2.5 million light years away. That is an outline of the methods we will be using to find stuff in each of the 4 seasons in the upcoming programs. I hope you will join us for the next Astronomical 101 programs, and the next program that we'll publish, I believe, will be How to Find Stuff Part 2 for the summer sky. As always, you can learn about all of our activities at our website. I hope you will continue to participate in our Astro 101 programs, and of course, and as always, keep looking up. Thank you.